Alright, it's time for the fourth installment of our Unit 4. It's too bad that there's not 4 forces, because that would have just been great if it was the fourth video, the Unit 4, fourth law, but there isn't a fourth law. But we're going to talk about Newton's third law, and interactions of different things. So, you can read about this a little bit more if you want in page 116 and 117 of your workbook, but think of a scenario. You slap a table, slap your hand on the table. What do you feel? Why do you feel it? You're trying to hit the table. But what happens is the table hits you. As you might have heard before, the table hits you. Same thing. When you kick a bowling ball, please don't do this. It's gonna hurt. It hurts your foot. Why? It kicks you. But really, it actually does apply a force back to you. It might not be kicking, but you get a force backwards. And that's because no matter what, any time in the world, forces come in pairs. You cannot apply a force without receiving a force. So think about pushing on a wall, anything, standing, no matter what you're doing, there's always an interaction pair. And this is where Newton's third law comes from. For every action, there's an equal and opposite reaction. This is a very general form of Newton's third law. Sometimes you will see the word force added in to these two spots here, so it is an action force and a reaction force, because we're dealing specifically with forces. It's not just that every action has an equal and opposite reaction. That is specific to forces. So, you push down on the desk pushes back. Skating, you push against the wall, you move backwards. The wall doesn't move, but you do. Even though you pushed on the wall didn't move, you did. A ball bouncing, jumping, walking, every single thing is a pair of forces. But the trick is they're not on the same object. So let's draw a free body diagram for the first thing. So pushing down on a desk. So we've got two objects being involved in this. We've got the person and the desk. So we have to have a free body diagram. FBD, say, of the desk here, and FBD of the person over here. So we've got, draw a free body diagram, the desk. I just want to highlight our interaction force. So there is gravity on everything always. I'm not going to put gravity in here just to simplify what we're looking at. If we're pushing down on the desk feels an applied force down. The person, if you push down on the desk, you feel pushed up, which is why if you're doing strength workouts, if you push down on something, your body tends to go up. Just like if you're doing a workout, you're pushing down, you get forced up. So the person feels a force of equal and opposite direction. So these two are equal and opposite. But the key here is the forces act on different objects. Sometimes people will take the third law and try to say, well, everything is equal. Everything balances out, so then how can you have anything that moves? Well, the force is acting on different objects. So it's not that one is being canceled out by the other all the time, because they're not acting on each other. So you've got an applied force on each one. This has some interesting, the third law brings in specific types of forces. So one of them that it causes, and we'll spend more time talking about this in the next couple of videos, we'll talk about tension, the normal force, and the spring forces. Tension is anything that has to do with wires, strings, ropes, anything that is a rope or rope-like. A normal force, this one might be the weirdest of them all, but it's probably the most important. It's what keeps us from falling, from going through tables, from being able to sit on a chair, is the normal force. And then spring forces is anything that, think about springs or elastics, anything that is stretchy and wants to go back to its original shape. So we'll talk more about those forces individually. They all kind of relate to Newton's third law. So there's a couple of questions that to just go over these concepts a little bit. And as always, physics is awesome.